So now for the practical session, we'll be applying KNN on the iris dataset that we've seen in class and previously as well. So I'm using Google Colab for this, and I have already uploaded the iris.csv file. I'll provide this to you as well in the other supplementary documents. So the first thing I do is import my libraries, and from these I import pandas. Pandas is used in order to import various datasets, and these datasets or files are used for further processing. So these enables for it to be created as a tabular set, and this tabular set can be used for matrix multiplications or can be used for extraction of multiple vectors. Then I create a simple reference to my file so that I can use this later. Once I have the reference, what I use next is the pandas function read CSV, and I'll pass this parameter. This is sort of redundant, but it's easier for me to change the file later if I need to. You don't have to do it every time. If you're only working with this particular file, you can substitute this over here. Once I do have the file, now this would upload the file. One thing that I can do is I can print some amount of data from over here to see what it may look like. Now this iris corresponds to this one, and what it would do is print the first few rows for me to see. So here we can see the first 5 rows are printed. We see the column names and the various Y labels that are assigned to it. So this is printed in turn of this print statement. Now what I can do is I can assign these values to a variable name data, and then from this I can extract the Y parts and I can extract the X parts. So the X columns are from 0 to 3 and the Y columns are the final or the last column. So what I'll do is I need all of the rows, and from all of the rows I need 0 to 3 columns. Please remember that the 4 over here is exclusive, so it would only include 0 to 3 columns over here. Then what I do is I get the final or last column, and Python has this easy method of getting the final column by saying the minus 1. So the negative index is here, specify the inverse or the calculation for counting from the inverted form of inverted side of your array. So this is all about reading the data. Once I have read the data, the next important thing that I need to do is fit the model and get some prediction in it. Now the model again resides in some libraries, so I'm adding those libraries from let me add the other 2 libraries as well. So getting back to the libraries, I have added the Nearest Neighbour classifier, which is in the case sklearn neighbors library. Then in order to do some train test data split, because we do know that we need to specify some amount of training data and some amount of testing data, so we get that from the model selection library in sklearn. And lastly, in order to calculate the accuracy score and other such parameters for measuring the progress, we get the SK metrics. So now the next thing I'm going to do is split my data that I've collected over here into training test splits. So I have an X train, X test split, and Y train and Y test split, and this I get by the train test split function. The parameters that I pass are the X and Y values, so it has X and Y from which to collect data, where the next I specify is the test size, and we'll say that the test size is like 0.3. This would mean 30% of our data. And then we say randomize or randomly initialize our data. once we've got the training and testing split, the next thing that we can do is initialize our classifier or create a classifier which would work on these. So I create a classifier object which would work on K-neighbor classifier and pass it the value for number of K or the number of neighbors that I require, which would be equals to 2. I've adjusted the spellings here. These are like this. So once we've got the classifier object, the next thing we do is we train this classifier. So I take that object that I previously created and use the fit function. So what the fit function does is it actually runs your classifier on the data that you provided. Now, which data will we be providing? The testing data, the training data that we have. So I give it the X train and the Y train data in order for it to learn the parameters or the best possible solution that it can. Once we're done with that, then we can get the final or predicted labels. These predicted labels would be now given on the test data. Let me repeat that. Once we have trained our classifier, the next thing that we do is run this classifier on the test data in order to get the predicted labels. So for test data, we do not provide it with any Y test. That would only be used in order to evaluate the results. We only provide it Y test and we get X test and we get the predicted labels. So the final thing that we're going to do over here is find the accuracy, and the accuracy can be measured by using the function accuracy score, and this accuracy score is between the Y test values and the predicted values. And we can go ahead and print this accuracy. So let's run this. So let's run this to see what results we get, and we have an accuracy of 100%. So this 100 means that we've achieved the full accuracy. Now this is perfectly possible because the data set we had was both small and it was very, very clean. So there is no problem or no issue of this being a 100% accuracy. The other thing or another thing that we can do is we can plot a confusion matrix over here as well. So a confusion matrix would help us see what the misclassified examples are. So it would tell us if there is anything that was wrongly predicted, and it would tell us what the correct prediction should have been and what the incorrect one was. So let me finish this up and let's run this again. And here we have a confusion matrix. So every row and column is equals to the classes. So class 1, class 2, class 3, and similarly class 1, class 2, class 3. So there were 19 examples of class 1 that are classified as class 1, 13 examples of class 2 that were classified as class 2, and similarly 13 for class 3. Since we have 100% accuracy, so it's not showing us any misclassifications. If there were any, these would be in the off diagonal of values of this matrix. So everything that is present on the diagonal is correct or properly classified, and everything that is off diagonal is misclassified. Now, there's one other thing that we can try, and that is plotting the data to see what it looks like. So let me get the matplotlib, because that would do the plotting for us, and I plot as PLT. Then I specify some parameters for class be very careful with the spellings over here. Specify green. So we specify colors for each of the classes we have. The next thing is to create targets that we can iterate over. So for every color value that we have, we are going to find a label from the Y, and then we are going to plot these using the scatter plot. So what I've done is I've created a scatter plot and I've made it two-dimensional instead of the 4 values over here. So for X, we take the values of the first column and the second column, and then we use the color as the one we have defined in the target. So now let's put all. So this was PLT and not plot. So let's run this and see if it works. Well, we've got some input. Let me delete these, and there we go. So now it's created a scatter plot for all of the values that we had in the original dataset. That's all for the practical session.